So already we discussed about the naphthalene under the polynuclear hydrocarbon unit. Now going to the various naphthalene derivatives. Here we will discuss about the naphthalene derivatives, which is the naphthols, naphthylamine, naphthoic acid, and naphthalene. Now coming to the first one is the naphthols. What is the structure of naphthols? Naphthol is the monohydroxy derivatives of the naphthalene. Monohydroxy means the hydroxyl group, one hydroxyl group present in the naphthalene. So we draw the structure, that is there is the two form of the monohydroxy derivatives. One at the one position and one in the another one in the C2 position. So that is the call is the on naphthol. When hydroxyl group present in the C attached at the C on position, and also that is the called the alpha naphthol. And when in the hydroxyl group attached at the C2 position, and that is the called the here is the 2 naphthol or beta naphthol. Now going to the direct synthesis of the naphthol, it is directly synthesis from the benzene, and you know already studied that the benzene is when heated with the concentrated sulfuric acid at low temperature it forms the naphthalene sulfonic acid, which is at the attached at the one position, and at the high temperature it's for the naphthalene sulfonic acid forms which attached by the C2 position. So from that reaction, by treating with the concentrated sulfuric acid and by applying or maintain the heat, we can obtain the alpha naphthol or beta naphthol. So reaction like that. So reaction like that, when naphthalene is treated with the concentrated sulfuric acid at 60 degrees Celsius, is formed the one naphthalene sulfonic acid, and when it is treated at a high temperature with the concentrated H2SO4, the sulfonic acid is react with the sulfuric acid, the part of the sulfonic acid, and the SO3H react with the C2 position, it form the 2 naphthalene sulfonic acid. Further, it is fusion with the sodium hydroxide at high temperature, likely about 300 degrees Celsius, is formed the corresponding 1 and 2 position sodium salt of the naphthol, and it is further acidolysis. It form the it yields the naphthol, which is the corresponding naphthol. If the reaction is the first one, that is the one naphthol or alpha naphthol, if the reaction is the second one, it forms the beta naphthol. The reaction is the same. after the treated with concentrated sulfuric acid. That's about that is the synthesis of the alpha and beta naphthol. Now going to the properties, and it's having the property that is the colorless solid, and alpha naphthol having the melting point 123 to 124 degrees Celsius, whereas beta naphthol having the melting point 96 degrees Celsius. And the structure show that the naphthalene reacts itself, the chemical reacts like the benzene. So naphthol is that reacts like the phenol. তো ফেনলের যে কেমিক্যাল রিঅ্যাকশন তোমরা দেখতে পাবে সেই কেমিক্যাল রিঅ্যাকশনে ন্যাপথল শো করবে। Now going to the specific chemical reaction which is important to you, that is coupling reaction and the Bucherer reaction. So in the chemical reaction of the naphthol, we going to discuss about the specific reaction of the naphthol. First one is the coupling reaction, and coupling reaction always carry out through the by formation of the azodide, or it is the phenyl. When the naphthol is react with the phenyl azo compound, azo means N2 compound, nitrogen, and that is the it forms the azodide, and that is the react at the fourth position where the hydrogen is present, and it is a react at the fourth position. It forms the azodide, and when the coupling reaction is carried out by the starting material as a beta naphthol, the reaction is the attack the phenyl azo compound is attacked at the one position. You can see that is the alpha naphthol, and that is the beta naphthol, and beta naphthol when react that same compound, it is formed one phenyl azo, because it reacts the one position, attack the C1 position, and it forms the one phenyl azo, beta naphthol, and that is the azodide. And there is another reaction, that is the Bucherer reaction, and Bucherer reaction normally carry out in the presence of the ammonium bisulfate at 150 degrees Celsius, when naphthol is treated with the ammonia. When naphthol is treated with the ammonia in the presence of ammonium bisulfate, you form the first, that is the form the naphthalene, and it's from the naphthalene, and that is the naphthylamine amine group present at the 1 position. If we treated the naphthylamine again with the H2SO4 and acidic hydrolysis, it form the naphthol corresponding alpha or beta naphthol. That is the also use is the you can also use here in the that is the synthesis of the alpha naphthol or is prepared from the naphthylamine. So এটা কি এটা এই রিঅ্যাকশনটার নাম হচ্ছে উজেরার রিঅ্যাকশন এবং এই রিঅ্যাকশনের মেইন যে সলভেন্ট ইউজ হয় যে রিএজেন্টটা ইউজ হয় রিএজেন্ট দ্যাট ইজ দ্য অ্যামোনিয়া ইন দ্য প্রেজেন্স অফ অ্যামোনিয়াম বিসালফেট এটা ন্যাপথাইল যে হাইড্রোক্সিল গ্রুপটাকে কনভার্ট করে অ্যামিন গ্রুপে সো আলফা আর বিটা ন্যাপথল দুটো করেসপন্ডিং ন্যাপথাইল অ্যামিন তৈরি হয় and if you then that is the in the presence of sulfuric acid treated in the acidic hydrolysis, then it is the form the alpha naphthol. And there is the another reaction of the naphthol that is the formation of the naphthyl ether, and here is the naphthol is react with the alkyl halide, I mean Ri, and sodium hydroxide or alcohol in the presence of H2SO4. If the naphthol react with the alkyl halide and sodium hydroxide or the reagent alcohol H2SO4, concentrated H2SO4, that is the R. Here is the H2 is in case of alcohol and the H2 is removed and form the OR. That is the OR. That is known as the naphthyl ether. And when we the same reaction is treated in with the beta naphthol, the OR is the here is the at a 2 position OR substitution occurs. So that is also the 2 ethyl naphthyl ester of the 2 beta naphthol or beta naphthol. That's about the naphthol, and it is mainly used in the dye industry. It is used in the dye industry, whereas the alpha naphthol is used for the insecticides, and beta naphthol is used. Alpha naphthol is used as the insecticides, and beta naphthol is used in the tanning agent. As a tanning agent, tanning agent মানে চামড়া শিল্পে লেদার শিল্পে যে লেদার শিল্পে যে use her beta naphthol as a tanning agent. There is another derivative of the important derivative of the naphtholene, that is the naphthylamine, and naphthylamine also having the 2 form because that is the alpha naphthylamine when it is attached at the C1 position, and another one is the beta naphthylamine when it is attached at the C2 position. Let's see the naphthylamine, their synthesis of the naphthylamine and important chemical reaction. And naphthylamine is the, if you see the structure of naphthylamine, you can see that and C1 position, that is the alpha naphthylamine, and in the C2 position beta naphthylamine, that is the beta naphthylamine, and we see that the properties, the chemical reaction which is a like a aniline group, like an aniline group, and it is synthesized by the two method. First one is the benzene react with nitric acid concentrate sulfuric acid, and it is the nitration process. And when benzene react, you can remember that I already studied that the naphthalene when react with the nitric acid and a nitration process, it forms the one nitronaphthalene, and it is further reduction with iron HCl. Iron is used here as a catalyst, and the nitro group is reduced to the amine group, and aromatic primary amine group NO2 is reduced to the NH2 group, and that is the alpha naphthylamine. And how we prepare about the beta naphthylamine, because in the nitration reaction of the naphthalene, we see that only the nitration attacks at the C1 position, so that for the preparation of the beta naphthylamine, the starting material taken, that is the beta naphthol. Beta naphthol, the starting material present, and which is the in the previous chemical reaction of the naphthol, you see in the chemical reaction of the naphthol, you see that it is having the one reaction আমরা already পড়েছি, that is the Bucharer reaction. Bucharer reaction এ কি হয়েছিল না, naphthol alpha বা beta naphthol in the presence of ammonia and ammonium bisulfate, এটি ফর্ম করেছিল কি, এটি ফর্ম করেছিল beta methyl amine, in where the starting material is taken beta naphthol, it is the beta methyl amine, and when the starting material is the alpha naphthol, it is the alpha methyl amine, and after the alpha methyl amine, by the removal of the water, molecule. So that's about the synthesis of the alpha naphthylamine, and by the starting material of naphthol, followed by nitration, and followed by the reduction, and for the synthesis of the beta naphthylamine, we taken the starting material as the beta naphthol, followed by the Bucharer reaction, and the properties, it is the colorless solid, and melting point 50 degrees Celsius from the alpha naphthylamine, that is having the melting point 50 degrees Celsius, and the beta naphthylamine, the melting point 113 degrees Celsius, 113 degrees Celsius, insoluble in water, soluble in the organic solvent like ether, chloroform, or if you going to the already described, it is that having the chemical reaction, and which is resembles to the aniline. Now going to the chemical reaction of the naphthylamine, and the chemical reaction, that is also the positive response to the diazoxidation reaction, and the diazoxidation, it is the positive reaction with the diazoxidation reaction, Now let's see the dihydrogenation reaction. Both alpha and beta naphthylamine both are susceptible for the dihydrogenation reaction in the presence of sodium nitrite and HCl less than 5 degrees Celsius, 0 to 5 degrees Celsius. N2 plus Cl minus. That is the N2 plus Cl minus, or N111 N plus and Cl minus, that is the dihydrogenation salt, and dihydrogenation salt is used for the various chemical reaction. When the dihydrogenation salt is the react with the copper halide, it forms one halide naphthalene or one halonaphthalene. That is the when the dihydrogenation salt of the naphthalene react with the sodium nitrite, it forms one nitronaphthalene. When is the hydrolysis, it forms the naphthol. When the react with the H3PO2, it forms naphthalene. And when react with the copper cyanide, one cyanonaphthalene is first formed, and one cyanonaphthalene reduced with the lithium aluminium hydride, that is the redox reducing agent. The cyanide is converted to the corresponding amine group, that is the CH2 NH2. And that's about the reaction of the naphthylamine. So reaction of the naphthylamine, first we have to prepare the dihydrogenation salt of the naphthylamine by reacting with sodium nitrite HCl, and the temperature is low, that is below 5 degrees Celsius, and dihydrogenation salt is susceptible to the various chemical reaction, and we already described here. And like the naphthylamine, like the naphthol, that is the naphthylamine also used for the preparation of the dye. The last two, that is the naphthoic acid and naphthoic acid having the structure, the carboxylic group attached at the C1 position, and that is the structure of the naphthoic acid. And naphthoic acid Kolbe synthetic reaction বা Kolbe synthesis এর through naphthoic acid টা তৈরি হয়, যেখানে আমরা ফার্স্টে in case of Kolbe synthesis normally carry out করা হয়. The starting material sodium salt of the naphthol, that is the ONA এর সাথে কার্বন ডাই অক্সাইডের রিঅ্যাকশন করে 150 ডিগ্রি সেলসিয়াসে ONA এর সাথে কার্বন ডাই অক্সাইডের রিঅ্যাকশন করে Kolbe সিনথেসিসটা অর্গানাইজ ক্যারি আউট করা হয়. তো sodium salt of the naphthalene is first prepared from the naphthol. নাফথলের সাথে সোডিয়াম ethoxide alcohol sodium hydroxide reaction করে sodium salt of the naphthalene first prepare করা হয়, which is the further subjected to the Kolbe synthesis and it produces the sheet naphthanoic acid. The reaction is carried out at the C1 position because the solvent is because the 2-hydroxy naphthol that is taken and so you can see that please correct the reaction scheme. The reaction is in the first 2 naphthol is react with the sodium hydroxide solution and it form the salt of the sodium salt of the 2 naphthol and it further subjected to the Kolbe synthesis in the presence of carbon dioxide at 150 degrees Celsius. It produces the 2-hydroxy on naphthanoic acid. 2-hydroxy on naphthanoic acid. Here is the starting material used is the 2 naphthol. And when how that is the 1 naphthanoic acid is produced by the Grignard reagent, where the 1 bromonaphthalene is react with magnesium to form the RMGBr, that is the Grignard. That is, you see that 1 bromonaphthalene that is react with magnesium that produce the RMGBr, that is the Grignard reagent, which is the further react with the carbon dioxide in the presence of the acid and it is the produces 1 naphthanoic acid. And last one is the naphthaquinone and naphthaquinone derivative. You have to only naphthaquinone derivative is a naphthalene containing the carboxyl group, carbonyl group. Sorry, there is a naphthalene containing the carbonyl group, 2 carbonyl group. That is the form the naphthaquinone. So you can see that here is the 3 types of form of the naphthaquinone. One is the 1,2, the carbonyl group present is the 1,2, that is the 1,2 naphthaquinone. And for that when on 2 position, that is the double bond is omitted, and when the 1 and 4 position, carbonyl group is the present 1 and 4 position, that is known as the 1,4 naphthaquinone, and when that is the or another form is that is the 2,6 naphthaquinone, and here is the present opposite position and that is the 2,6 naphthaquinone. There is the 3 form of the naphthaquinone. That's all about the naphthalene and its derivative. So we have studied about the naphthalene, their structure, and after that we studied synthesis, and further we have studied the various naphthalene derivatives like naphthol, naphthylamine, naphthaquinone and naphthoic acid. That's all about naphthalene. In further we will discuss about the next polynuclear hydrocarbon, and that is the anthracene. Here is the, you can see that there is the three structure. You already know the structure. First one is the structure of benzene. Second one is the structure of the naphthalene. Third one is the structure of anthracene. Now discuss about the resonance energy. তো প্রত্যেকটা মলিকুলার একটা ইন্টারনাল মলিকুলার এনার্জি থাকে এবং মলিকুলার এনার্জিটা দু রকমের হয় ফর দা ইন কেস অফ দা কনজুগেটেড রিং সিস্টেম, বিকজ কনজুগেটেড রিং সিস্টেম shows the resonance, and in the resonance so there is the two type of the energy, and first one is the, you will draw the here is the energy. First one is the, that is the expected energy, that is the energy of a molecule or organic compound which is the actual energy of the compound. এটা আমি অ্যাকচুয়ালি ডিসকাস করতে যাচ্ছি তোমাদের যে ভেরিয়াস কোশ্চেন আছে, যে কোশ্চেন ছিল যে রেজোনেন্স এনার্জি তার সাথে স্টেবিলিটির কি সম্পর্ক, যেটা অলরেডি ডিসকাশন ক্লাসে পেয়েছিলাম আমি, তো সেটা ক্লিয়ার করতে যাচ্ছি। তো দুটো এনার্জি থাকে, ওয়ান ইজ দ্য এক্সপেক্টেড এনার্জি, দ্যাট ইজ দ্য অ্যাকচুয়াল এনার্জি অফ দ্য মলিকুল, and that is also known as the hypothetical energy, and second one is the after the resonating and due to the resonance form, and you already know that that due to the resonance there is a various canonical forms or the resonating structure have been observed in case of benzene, in case of naphthalene, in case of anthracene, in case of phenanthine, and resonating structure টা কেন হয় for the stability of the molecule due to delocalization. এই স্টেবিলিটির জন্য যে মোর স্টেবল রেজোনেটিং যে স্ট্রাকচার তার এনার্জি যেটাকে বলা হয় রিয়েল এনার্জি। তো আমরা দুটো এনার্জি দেখতে পারি, একটা অ্যাকচুয়াল কম্পাউন্ডের এনার্জি আর একটা হচ্ছে তোমার আরেকটা রেজোনেটিং স্ট্রাকচারের বা কম্পাউন্ডের রেজোনেন্সের জন্য যে মোর স্টেবল রেজোনেন্সটা পাইছি তার একটা এনার্জি। এই দুটো এনার্জি, এই রিয়েল এনার্জি, that is also known as the resonance energy, and that is the resonance energy, more stable resonating structure, energy of the more stable resonating structure, that is the real energy. So what is the resonance energy? Resonance energy is the difference between the actual energy of the actual compound and energy of the more stable resonating structure, more stable resonating structure, that is দুটো ডিফারেন্স কে বলা হয় রেজোনেন্স এনার্জি। So you can say that এখানে একটা জিনিস জানার আছে যে রেজোনেন্স এনার্জি, রেজোনেন্সটা কেন হয় তোমরা সবাই জানো, রেজোনেন্স ডিলোকালাইজেশন অফ ইলেকট্রনের জন্য হয় আর যেটা স্টেবিলিটি প্রদান করে মলিকুলকে। তো মলিকুলের যে স্টেবিলিটি প্রদান করছে, স্টেবিলিটি মানে এনার্জি কম, সো দ্যাট দ্য মোর স্টেবল এনার্জি, মোর স্টেবল যে রেজোনেটিং মলিকুলটা হবে তার যে এনার্জি এক্সপেক্টেড এনার্জি বা অ্যাকচুয়াল অ্যামাউন্ট থেকে কম হবে, কারণ ইট ইজ স্টেবল, ইটস দ্য লোয়ার দ্য এনার্জি। So and that is the difference between the expected energy and the real energy due to resonance effect, or you can say that the how much amount is less than the actual amount due to the stability of the compound by resonance effect, that is known as the resonating energy. So you can say here it is the very important point, what is the relation between resonance energy and stability. একটু তোমরা ডিপলি একবার ভেবে দেখলে দেখতে পারবে যে রেজোনেন্স এনার্জি আর স্টেবিলিটির মধ্যে ডিফারেন্সটা কিভাবে হবে না। তোমরা ইন কেস অফ বেনজিনের ক্ষেত্রে, বেনজিন এখানে আমি তিনটা স্ট্রাকচার দিয়েছি যেটা তোমাদের সিলেবাসে অন্তর্ভুক্ত আছে, বেনজিন, ন্যাপথলিন, অ্যান্থ্রাসিন। ইন কেস অফ বেনজিন, ন্যাপথলিন, অ্যান্থ্রাসিন, বেনজিন এটা আমি একটু পরে আসছি, বেনজিন, ন্যাপথলিন, অ্যান্থ্রাসিনের রেজোনেন্স এনার্জি। বাট তোমরা এটুকু দেখো যে রেজোনেন্স এনার্জি, that is the not a energy, that is the difference between the actual compound energy of the actual compound and energy of the most stable resonance. So যে compound বেশি রেজোনেন্স শো করবে, I mean higher the canonical form শো করবে, তার রেজোনেন্স এনার্জি, যার যে ডিফারেন্সটা আরো বেশি হবে। কারণ কোন কম্পাউন্ড, যেমন তোমরা एग्जांपले নিতে পারি নরমাল অ্যালিফেটিক एग्जाम 1,3-butadiene or that is that this compound has the 2 pi electron, this compound has the 3 pi electron, so that is so the more resonance structure. So here that is that the resonance energy is the much lower than the expected. So here is the resonance energy, that is the real, and that is the resonance. Here is the difference is the more, because of the here is the resonance extent is the more. So we can say that when the resonance is the or more canonical forms is the more, the difference between the expected and real is the more, the compound is the most stable. So we can determine, we can write that the resonance energy is proportionally the stability. Resonance energy is the difference between the actual compound energy and the resonance energy. So energy difference between the actual compound energy and the most stable resonating structure are called the resonance energy. Higher the canonical form, the compound is the more stable, and so the energy is the less. Higher the canonical form, compound is the more stable, so energy is the less. So the difference between the real and the resonating energy is the higher. So higher the resonating, that is the known as the resonating energy, and higher the resonating energy increase the stability. Now going to the why the stability of the naphthalene is less than the benzene, and then the anthracene also less the benzene, because benzene having the resonating energy 36 kilocalorie per mole, and naphthalene having the 61 kilocalorie per mole, and whereas the anthracene having the 84 kilocalorie per mole. But in case of, as compared to benzene, naphthalene is the less aromatic, because benzene consists of the 6 pi electron, and where you can see the naphthalene that is composed of 2 benzene by fusion, and that compared that 2 benzene that compare 10 pi electron as compared to, but it is when 2 benzene that it not contain the 12 pi electron, that is the 10 pi electron. So that is the fused of the 2 benzene. So you can say that is the energy, resonance energy is the less than the isolated 2 benzene. So that is the, you can say that is the less aromatic than the benzene. And in case of the anthracene, it is also the resonance energy also is the less than the 3 separated benzene. So that is also the less aromatic than the benzene, and that's why that is the reactivity is that increases of that cases. I think you all are the clear about whatever the resonance energy, what is the resonance, and what is the expected actual energy which is expected, that is known as also hypothetical value, and what is the resonance value, and their relationship between the stability of the and the resonance energy. I think all about clear. If you any doubt, you can we will discuss about the further classes. Thank you.